All right, so today's lesson is on representing and interpreting linear relations. So a linear relationship can be identified if you simply look at the scatter plot of the data. So you can call a relationship a linear relationship if you see that the trend that it seems to form is evident by a straight line. So I can see that in this first graph here, I can see that all the data, all these data points on this scatter plot seem to sort of form a straight line, right? So it's saying to me that as the husband's age seems to be going up, so is the wife's age. So to collect this data, they would have asked couples, married couples, what their ages are. Right, so for instance, my dad is 70 and my mom is 68. So their plot would have been, somewhere around here. And what this is showing is that typically a husband and wife's age tend to be very similar, right? So in other words, like, a younger man tends to be married to a younger woman. And older men tend to be married to older women in the same sort of generation, by and large. Now, of course, there are situations where the wife is much younger than the husband or vice versa, but typically in our society, ages tend to match. So this is an example of a linear relation. In the next example here, I can see that there's definitely some kind of relationship going on, but it wouldn't be called a linear relation because the scatter plot does not create dots that could be sort of represented by a straight line. Now, so let's look at interpreting what's going on here. So in this particular graph, they're saying test scores and how they depend on the hours studied, right? So it looks like if you start with 0 hours studied, that your marks, for the people that were polled for this, your marks tend to be lower. Now, it seems that as you increase the number of hours that you study, your test scores are going to go up. However, once you sort of reach, it looks like it's somewhere between 10 and 15 hours of studying, it looks like your marks start to drop again, right? So I think what they're trying to say here is that there's a sort of an optimal or best number of hours to study, and after that, it really doesn't make as much of a difference. But the point of this lesson is on linear relationships. This is definitely not showing a linear relationship, even though there is a relationship going on here, right? So I would probably see that there's some kind of a curved trend here. Now let's look at the last graph. This last graph here is looking at the number of calories in food versus the amount of sodium or salt content, right? Now I can see in this graph that all these points are scattered all over the place. There's no linear relationship. There doesn't seem to be any kind of relationship between them. So let's look at interpreting this to make sense of it. So when I look at calories are, when you're looking at on the side of a package of food, you're looking at the nutritional content. They'll usually tell you the calories, as well as the sodium content. But the sodium is just one of the points about nutrition that they might talk about. But the calories sort of tell you the overall amount of fuel that you can get from your food. Now, of course, every type of food has calories, pretty much. Some maybe more than others, but not all types of food contain a lot of sodium, right? So like, for instance, table sugar, that sugar that you might put in coffee or whatnot, that doesn't contain any sodium whatsoever. So what this graph is trying to say is that, there's really no relationship between the number of calories in your food and the sodium content. So you can have high-calorie food with no sodium content, some high-calorie food with lots of sodium content, and so on and so forth. They're really not connected in any way. So often when a scatter plot shows a linear trend or a linear relationship, you can draw something called a line of best fit in order to show that relationship exists, and also to help you make some estimations about information that you don't have. I'll explain that in a little bit. So let's look at the term or the phrase, a line of best fit. So it's a line, first of all, a straight line, and it says best fit. So we're going to try to draw a line that's going to represent that is the best fit for the data set that you have. So what I would do is I'm just going to insert a little line here to show you what a line of best fit might look like. So I would draw a line through the data set, and I'm going to highlight that in some different colors. I'm going to outline that maybe in red to highlight it a little better, and I'm going to make it a little thicker so you can see it better. Right, so there I've got a line showing up, and the line is sort of representing the entire data set. Okay, that's what my line of best fit would be. So I'm going to talk a little bit more about some basics around line of best fit, how to draw it, how not to draw it. If I take this line and I try to put it in over here, there's no way that I can fit that line to have it really represent this data set. So it wouldn't make sense in this case to draw a line of best fit. In this case, I might draw a curve of best fit instead. So let me show you what I mean by that. I'm going to get some red pen going here. I might draw a line that kind of goes through, and this is a little rough, but basically goes through the data set to represent it. Now in this last set over here, it doesn't make sense to draw any line of best fit. I could I could try to fiddle with this, move it around like this or whatever. There's no way that that's going to show any kind of relationship for the data. So there's no point in putting a line of best fit through that. So I'm going to give you some guidelines about how to draw a line of best fit, and then we'll go back and we'll practice some of those skills. So here are the guidelines for drawing a line of best fit. Now, of course, they're guidelines. They're not strict rules. When I am going to be looking at your work and when you've drawn a line of best fit, you need to know that I'm looking to see if you made a good effort towards doing this. Everybody, if you're drawing a line of best fit by hand, everybody's judgment is a little bit different, so your lines are not going to be exact, right? But I want you to try and show me that you understand how you should and should not draw a line of best fit. So the line should try to go through as many of the points as possible. That can be hard depending on the data, but you basically want your line to be representative of the trend. So what I mean by this is, I'm just going to get a line going here. It wouldn't make sense for me to draw a line of best fit that looks like that. I'm just going to make it a little thicker here, because that really doesn't represent the data, right? I wouldn't draw it sort of like that either, because it's not really going through most of the points, and it's also not representing the data. So I would, try to fit it to go, try to guesstimate to have it go around like maybe like that. All right, so the line has to represent the trend. There should be about the same number of points above and below the line, right? So when I look at this, I've got 1, 2, 3 points above, 1, 2, 3, 4, and I've got, maybe 1, 2, 3, 4 below. So that actually looks pretty decent. But I could always adjust if I felt like it was in the wrong spot. So if you have a clear ruler when you're drawing your line of best fit, you can sort of just fit that over top of the data and move your ruler around until you can count the number of dots above and below. That one doesn't always work in every situation, the counting of the dots. It's more important that you look at the trend. For example, it wouldn't be correct for me to draw a line of best fit where, here half of them might be above and below, but it doesn't represent the trend at all. So let's get that back, maybe something like around there-ish. Okay, you should not only use the first and last data points to form your line. So what they're saying here, what I'm trying to say here, is I'm saying you don't need to start on this first one and end on this last one. Now in this case that turns out to be not so bad, but you may find that with different trends that doesn't really work so well for you. Okay, so in this case it's not so bad, in other cases it might not work so well. So I'm going to just change that up a bit. The line of best fit does not need to pass through the origin or 0, 0. So don't think that you need to make it go through 0 and then fit the rest in, right? That doesn't represent the trend. So those are the basics. There's a couple of other terms that I want to talk about. And so when you see the trend, you can kind of fiddle, maybe draw your line of best fit in pencil when you're first practicing. and then see how that works out for you. I can check it as you're working through your homework. So why people in the world of science and math actually use a line of best fit is to make some estimations. So in certain cases, you haven't collected all of the data that you need, but maybe you want to make some predictions. They use this a lot in marketing to make predictions about the number of items they might sell, depending on the cost, or different things like that. Scientists will often make predictions about data that they can't collect, either because it's not possible to be collected or they haven't collected it yet. So I'm going to talk to you about a couple of different terms related to the line of best fit, different ways that you can estimate. So the first term is something called interpolation or interpolating. Okay, so I want you to pay attention to the in here, because interpolating means estimating inside the data set. Okay, so I can see very clearly here that my first data point starts at a temperature of 12 degrees Celsius, and my last data point here starts at, it looks like it's, right at maybe 25 degrees Celsius, between 24 and 25. There's 25, or 24 and 26 rather. It's 25. So that means that the estimation, if I'm interpolating, is going to have to be between 12 and 25 degrees Celsius. So I'm going to give you an example of interpolation for this particular data set. So before we do that, let's interpret what this means. So if I'm looking at this particular data set, I'm looking at cost versus temperature, right? So maybe, for instance, if you are, maybe you can think of an example of where this might be used. Maybe the cost of a condo in Florida per week or something like that depends on the outside temperature. So usually people visit Florida when the weather's nice, and so perhaps as the weather outside gets hotter and hotter, then people who own condos there that want to rent them can charge higher fees. That's just one example. There's probably other examples for this data and what it could represent, but there's one. So let's say you had a condo and you wanted to say, okay, well, when the temperature is let's say 21 degrees, what should I charge, right? What should I charge for my condo? So I would say, okay, well, I don't actually have a data point for that. There's no evidence there, but I do have my line of best fit right here. And so my line of best fit, so what I would do is I would go ahead and I would draw a little line. I'm just going to kind of draw a rough one here. You would probably want to use a ruler, but I get up to right here. And then maybe what I'll do instead is I'll draw some lines to show that a little bit more clearly. All right, so here I am at 21 degrees Celsius, and I want to know how much to charge for this condo. And then what I want to do is, okay, well, I know that's where my line of best fit is, and that represents the trend or the relationship. So now I'm going to say, okay, well, where does that go over here on my vertical axis, on my cost axis? Well, if I follow that right across, it looks to me like I'm between $400 and $500. And if I had better grid lines, I could estimate a little bit more closely. So if I had to make a guess, well, what would be a good guess? Probably somewhere around $490 for the week. That may be what I want to charge in that case. And so with that line of best fit, I've interpolated because I've looked at within the data set to make an estimation. And now, sometimes we don't have all of the data collected beyond the data set, right? So like, for instance, the lowest point that I have on this data set is at 12 degrees Celsius, and the highest one is at 25 degrees Celsius. So if this were representing the weather in Florida, the weather in Florida gets a whole lot hotter than 26 degrees Celsius. And so I might want to say, okay, well, what should I charge for my condo if it's 30 degrees Celsius out? So in that case, to make that kind of an estimation, I would need to do something called extrapolating. Okay, so notice the X here. That means I need to extend my line of best fit because this involves estimating outside of my data set, not inside. So I'm going to just quickly get rid of these interpolation lines. And what I'm going to do is I'm going to create some extrapolation lines, but my line of best fit doesn't quite fit into the whole scheme of things. If I had this on graph paper, I might want to extend my line beyond here. For the purposes of this, what I'm going to do is I'm going to extend my line back here. So let's say, for instance, the question said, well, let's say it was 10 degrees Celsius outside. What should I charge for rent for that month? Let's say it's been an unusually cold Florida winter and it's 10 degrees out for the particular week. What should I charge for rent on my condo? So I extend my line back. I'm going to use a nice ruler, extend my line back, and then I'm going to see where I end up. So let me just insert some lines here to show you. So I'm going to start at 10 degrees. I'm going to just follow that up to my line. In this case, I really don't even need to do that because it's right on my axis, but just to keep things consistent, I'm going to just make this a little heavier so we can see it. So when I look at this, I can see that my line goes up to just about a little bit over $100. So, I would guesstimate that point right there is probably at around $110 US. But, why is this extrapolating? Because I'm looking outside of my data set and I needed to extend my line in order to figure that out. So really, you're kind of doing the same thing, whether you're interpolating or extrapolating. It's kind of just an issue of, you need to understand what the question's asking you. So inter, inside, extend. So we're going to look at a couple of examples to help you understand this a little bit better. Okay, so here's an example of how you might be able to use a line of best fit to make some predictions by either extrapolating or interpolating. So I can see here first off when I look at this graph that it seems to form a linear relation. All the scatter plot dots, all the points that have been plotted seem to form a straight line trend. So this is a place where I can comfortably draw a line of best fit. When I try to interpret what this graph is saying, I look, well, it says height in inches here and weight in pounds here. So it looks as though we're trying to see if the height of this person or thing, there's no title, so it doesn't tell me, so I might have to figure that out. Height versus weight in pounds. And it seems to me whether they're seeing if the height depends on the weight. So I'm going to give you an example of where I think this data might be coming from. When you have newborn babies and they are very young, the doctor wants to check up on them fairly often to make sure that they're growing properly, right? And one way that they do that is they measure their height and they measure their weight. So and they might have also look at their age as well. So they want to make sure that the baby's growing properly, and by looking and comparing their height and their weight and their age, that can help you figure out whether they're maybe missing some nutrition or there might be some health issues with the baby. So I'm going to first off draw a line of best fit. The question says draw a line of best fit for the scatter plot at the left, then use it to help you answer the questions below. So I'm going to insert a line. And so remember, when I'm doing a line of best fit, I want to try to make it representative of the data. I don't need to go through the origin 0, 0, but I do need to make sure that it represents the data. So I'm going to draw this, and I'm going to just sort of fiddle. That looks pretty good. If I had to eyeball it, it looks like I have about the same number of points before or above and below the line. But of course, this is sort of, individual. You kind of have to, if you're doing it by hand instead of using a computer, then it might take you a little, there might be some human error in there, right? Everyone might have a slightly different line of best fit, but, that looks like a good one. I followed most of the rules, and it seems to represent the trend. So now it says to me, the question says, predict the height of a 20-pound child. All right, so sometimes I don't have the exact data point. I don't want to look at the data points anymore anyway. I want to use my line of best fit because remember, that's sort of representing on average what the trend is. So I'm going to insert a different color line now, and I'm just going to follow that up. So I'm going to start at the 20, It's really helpful to have a graph with grid lines because then you know that you're drawing a straight line and you don't have to estimate as much. But this is, 20 is one of the tick marks on here, so I can use it. I'm going to go straight up to my line of best fit. And I'm going to draw that. Again, you want to use a ruler to be accurate. And so I'm going to use that first part to help me draw across. I'm going to outline that maybe in green, and I'm going to thicken it up. Now, what I'm going to do is I'm going to do the same thing. I'm going to follow where I started and go all the way over to my vertical axis. Okay, I'm going to draw a nice, as straight as I can, horizontal line. That looks pretty good. Now, I'm not going to thicken that up because I can see sort of where it's going. Now, again, the more grid lines you have on your graph, the more accurate you can make your estimation will be. When I look at this in terms of height in inches, I'm between 20 and 30, not at 25. I'm a little bit sort of closer to 30. So I might say that that's at like 28-ish. So I think it's fair to say, because I don't have a lot of grid line there, to say that that might be 28. So this is a measurement. I'm going to write out 28, but I need to also remember to include the units. In this case, it's 28 inches. So I'm going to just put inches. I can use just the short form there. All right, so there I've answered this first part. Now, the question didn't ask for this, but is this interpolation or extrapolation? Well, in this case, it looks like it's interpolation because I'm looking within my data set. All right, so now let's take a look at the second question. It says, predict the height of a 50-pound child. So the 50-pound child, I don't have any data points for that, right? Maybe this is a baby that is unusually large for the typical patients that come in. And so that requires that I extend my data line. So I'm just going to actually extend that out, trying to keep the same line of best fit all the way out here. So let's take a look at that. I'm going to insert a line. I'm going to go from 50 all the way up to my line of best fit. And then I'm going to go ahead and do the same towards my vertical axis so I can see where my line of best fit takes me, what the corresponding height is. Okay, so there I am. So when I estimate, it looks like I don't actually have another tick mark here. If I were to measure the distance between 30 and 40 and translate that up, I don't think I'm quite at 50. Looks like I might be at 47, 48. Without the grid lines there, it's kind of hard to tell. So I'm going to say 47. And I'm going to include my units. So another way of writing inches is to do that. So there, I've been able to answer that question as well. Now in this case, it looks, I had to extend my line, so this would be considered extrapolation rather than interpolation. So now what I need you to do, we're going to complete the investigation together. Once you're done your homework question, I just need to see that you understand what you've just learned in the video. So on page 170, number 1, in your workbook, that's what I would like you to complete. When you're done that, then we'll have a conversation as a class about the investigation and what you're to do.